Hello everyone. Today I am going to discuss about a topic named as development of surfaces. Right. So what do you mean by development of surface? Here development of surface discuss with the solids like prisms and pyramids. Now if you see the definition of development of surfaces, so the complete surface of an object laid out on a plane is called as development. Means if you see this square prism, if you open up all the surfaces and keep it on a paper, then that is called as development of surface. Now we have a classification in this topic, that is classification of objects actually. So solids bounded by plane surfaces, examples as prisms and pyramids. And the next one is solids bounded by single curved surfaces like cone and cylinders. So if you see the solids bounded by plane surfaces, these are the examples. These two are prisms and this is pyramid, right? So if you see prism, this is the top and this is the bottom, and this is 1, 2 and back side 3 and this side 4. We have 4 rectangular surfaces. So as the square is having 4 sides, we will be having 4 rectangular surfaces. And if you see the next example, this is hexagonal prism, and it is having again top and bottom and 6 hexagonal rectangular surfaces. And this is pyramid, right? So in the pyramid we'll be having base, a flat square shaped, and top is the apex. This portion is the apex, we know that. But so what is the difference between this prism and pyramid? In case of prism we'll be having all the rectangular surfaces vertically, but in case of pyramid we'll be having triangular surfaces. This is a triangular surface and this is also a triangular surface. So this is example of first one, prism and pyramid. And if you see the next one is solids bounded by single curved surfaces. Examples are cone and cylinder. So this is cylinder and this is cone. If you observe these two, the surface of this cylinder and cone are smooth. Okay. So unlike a square prism, we don't have any edges. We will be having a smooth surface here. So this is the different two types of prisms and pyramids, and cone and cylinder we are going to discuss in this topic. And I'm going to start with the first example, development of surface of square prism. Right, this is a problem one. So here he has mentioned a square prism. This is a square prism of base side 40 mm. So square prism having a base side of 40 mm and axis 80 mm. Axis is nothing but height. So is resting on its base on the HP. So it is resting on its base on the HP such that a rectangular face of it is parallel to VP. So for a square prism, how many rectangular faces we have? We'll be having 4 rectangular faces. Okay. So out of 4, 1 rectangular face is parallel to VP. So draw the development of the prism. So let us assume this arises as a square prism. So and assume this plane of paper is the horizontal plane, right? It is resting on HP. If it is resting on HP, in the top you can see the square shape, right? And in the front view you can see the rectangular box, right? So front view will be a rectangular box and top view will be a square. So now I'm going to draw the front view and top view of this square prism now. So first I'm going to draw the top view, because in the top view only you can see the square shape, right? So this is square prism. So I am giving numbers as A1, B2, C3, D4. I am taking projections up to here. And he has given height as 80 mm. So I am taking roughly some value. In the drawing sheet you have to take exactly 80 mm as height. Right, this is completed and this is bottom. So let us assume this is A dash, and here we have D dash, and 1 and 4 dash will be lying upwards. 1 dash, 4 dash. It is front view. And here you can write 3 dash, 2 dash, and this is B dash, C dash. Now we have to draw the development. So what is development is nothing but opening of all the surfaces. How many rectangular surfaces it is having? 4 rectangular surfaces. So each rectangular surface length is equal to the side, that is 40 mm, and height is 80 mm, which is axis. Okay. Now so first to draw straight line and draw a rectangular box whose length is equal to 4 times the side. Why? Because if you, what is the length, you make it, what is the length of this rectangular box, you make it out, that is nothing but 4 times the side of the square prism. If you see the duster here, this is 1, 2, this is the third side, and this is fourth side. We have 4 sides. So what is the each side length? Each side of length is having 40. 40 into 4, 160. So this distance will be equal to, this is equal to 160, and you know this is mm, right? Now divide it into 4 equal parts. Why you have to divide it into 4 equal parts? Because this is a square prism having 4 sides. Each side is having 40 mm. So divide it into 4 equal parts. So this is 1, 2, and 3. Here you get some 1, 2, 3 equal parts. Okay. So even though it is looking non-equal, I am not in exact dimensions here. Now start with, this is A1, B2, C3, D4, E5. So this is how you have to draw the development, and you may get a doubt, what about top and bottom? So in the development of surfaces, we neglect the top and bottom, because if you take a square prism, the top and bottom will be a square. If you take a pentagonal prism, the square and top and bottom will be a pentagon. Like that, we don't need to bother about the top and bottom here. We only focus on the development of the sides of the rectangular block. Okay. Now this is the basic problem regarding to this square prism, but in general what happens is, the problem will be like this. For example, if you go to the first part like this, here this is a square prism and it is cut by some section plane. Section plane is nothing but a cutting plane like this. It is cut by some section plane, and this above portion is removed. This portion is removed, and we have to draw the remaining portion development. So in the examination, you may get problems like this. There will be a square prism or square pyramid or whatever it may be. It is cut by some section plane through some portion. It is removed, and you have to draw the development of the remaining portion. Okay. So we'll discuss one example like that. And this is the, see, a question. A hexagonal prism of side 30 mm, side is 30 mm and axis 75 mm long, is resting on its base on the HV. This is also resting on HV, such that a rectangular face is parallel to VP. So he has mentioned that rectangular face is parallel to VP. As it is a hexagonal prism, it is having 6 rectangular faces. It is having 6 rectangular faces. Out of 6 rectangular faces, 1 rectangular face is parallel to VP. Next, it is cut by section plane So it is cut by section plane, that is cutting plane. Section plane is nothing but cutting plane. Some part is removed, okay, and that section plane is perpendicular to VP and inclined at 30 degrees to HP. So we have to cut the solid such that the section plane is making an angle of 30 degrees to HP, right? So one more condition is given: the section plane is passing through the top end of the extreme level edge of the prism. Draw the development of lateral surface of cut prism. Okay, so first I'll draw the front view and top view of this hexagonal prism. I'm going to draw the first XY line, right? So after that, I'm going to construct a hexagon. Like this. So A1, B comma 2, C comma 3, D comma 4, E5, F6. So project all the points to get the front view. So this is how you are going to get the front view in case of hexagonal prism. Okay. Now also darken. This is A dash. This is 1 dash. Here you can see B comma 2, F comma 6 are having the same common line. So we can write in the bottom B comma F, and we can write 2 comma 6 dash. This is also dash, and here C comma E dash and 3 dash 5 dash. This is D dash. This is 4 dash, right? Now first, later on you have to draw the development of the hexagonal prism. So now my question is, what is the length we have to draw from here to here? That will be equal to 6 times the side given. Why we have to take 6 times the side? Because hexagon is having 6 sides and each side is mentioned as 30 mm. 30 into 6, that is 180 mm. So draw the development which is equal to 180 mm. So I am taking a rough scale here, not exact dimensions, but in the drawing you have to take the exact dimensions. And this 180 mm should be divided into 6 equal parts. So each part will be of 30 mm. Okay. So and here also we can give numberings. Remember, this left side number should be given at the beginning of this one. Always start the beginning numbers, starting number from left side only. Okay, so here should be A. If it is A, this should be A. Then only you are going to get the good diagram with proper understanding. This is A dash, 1 dash, B dash, 2 dash, C dash, 3 dash, D dash, 4 dash, E dash, 5 dash, F dash, 6 dash. And what is the last one? Again you are going to get the last one as A dash, 1 dash. So this is the general development of the diagram according to the problem given. But the question is, it is cut by section plane. Let us assume this scale is a section plane which cuts the solid like this. So here it is cutting the solid like this, and this above portion is removed and only bottom portion will be remaining. We have to draw the development of this one. So for drawing this section plane, he has given condition that it is cut by section plane perpendicular to VP. Okay, above XY line this is VP and below XY line will be having HP. We know that. Inclined 30 degrees to HP. This section plane it is inclined at 30 degrees to HP like this, and the section plane is passing through the top end of extreme level edge of the prism. So we have two top ends of the prism. This is one top end, this is second top end. If it is making 30 degrees like this, if you keep the section plane like this, and it may not cut the solid, but if you keep the section plane here with an inclination of 30 degrees, see this angle with respect to XY is 30 degrees, then we are going to get some section portion. Okay, so like this, from the extreme position here, draw the section plane. So we call it as section plane, and here this section plane is passing through like this, and this angle is 30 degrees. Okay, passing through one of the extreme level edge. Now if you observe, it is cutting this solid at different locations. This is first edge, there is A1. It is also cutting B2 and F6. B2 is in the front side and F6 in the back side, and C3 E5, C3 in the front side and E5 in the back side, and D4. Okay, so plot the points. This is let it be, we can take any number. So we already have A B C D E F, so I'm taking G. G is on A1, and on B2 we can call it as H, and on F6 we can call I, and we can take here J comma K. J is on C3 and K is on E5, and here it is L. Now project all these points towards the development of surface. So we know G is lying on A1. Where is A1? Here we are having A1. So this is G dash. This position should be parallel to XY line. Remember that. And this is this is H on B2 and I on F6. You can extend this to get the point I. So this is I dash, H dash, and next one you can take JK. So J is lying on C3 and K is lying on E5. This is the point for J, and this is the point for K, and the last one D, L is lying on D4. Here we will be having L dash here. Now G, H, J, L, K, I, and here G is lying on A1. A1 we are also having at the end, right? So we have to extend this. You may get it at why we are getting A1 at the beginning and A1 at the end. See here, if you start opening the surface from here, this will be opening like this, and this A1 is split into two parts. This is A1 and this is A1. That is what we are going to get, two positions. And this is G dash. Now join this surface with the help of scale. Then you are going to get the right? So this is how you have to draw the solution. So this portion from here to here like this, which is going to remain after sectioning the solid at this location. If you remove this portion, that is, this portion is getting removed, this part and this part is getting removed, only this remaining portion will be there, that we have to plot here. So this is how we are going to solve this problem. In the next lecture we are going to discuss some more problems on pyramids, cone and cylinder. Thank you.